Hey guys, welcome back. It's Mr. Jet. We're going to start talking about solving logarithmic functions today. So we've been solving exponential functions. Now we're going to start looking at solving log functions. Today we're just going to look at solving when they have one log in them. We will move on and we'll talk about when there's multiple logs or logs on both sides of the equation. But for today, it's just one log. So just a little bit of review. Remember that a log function, exponential function, are inverses of each other. So they cancel each other out. And so we're going to look at today when we're solving logs, we're going to exponentiate both sides. The opposite of when we were solving exponentials, we took the log of both sides. So remember, if we look at these examples here, if I take the log base 2 of 2 to the x squared, I have base 2 in my exponential, base 2 of my log. They cancel each other out. It gives us just x squared. Same thing here. Log base 6 of exponential base 6 cancel each other out. Just gives us ABC. When I go over here, same thing. I have a natural log, and then which has base e, and then I'm taking an exponential to that natural log base e, so they cancel each other out. Gives us x minus 1. Same thing here. I have an exponential with base 4 of to the power of log base 4. Cancel each other out and gives us just x. So this is what we did before. Now we're going down here and talking about solving logs. And so again, the inverse of a log is an exponential. And so what we're going to do is we're going to exponentiate. Okay, so we're going to take this log and we're going to make it an exponential with the same base. And that's going to cancel it out and allow us to solve it. It's going to give us a linear. It's going to give us a quadratic. It's going to let us solve it. So our steps, case 1 is the first type, again, where we just have one log on usually the left side of our equation. And so what we're going to do, same thing as what we do with the exponentials, is we're going to isolate. Okay, so we're going to get the log by itself. And then we're going to exponentiate both sides. That's going to cancel out the log, and it's going to allow us to solve it. So first example here. Again, here's my log. I need to isolate that first. So I'm multiplying by 5. So in order to isolate that log, we're going to divide both sides by 5. Then what we're going to do is we're going to take that and we're going to take both sides 3 to that power. Okay, so it's going to become 3 raised to the log base 3 of x equals 3 to the third power. So I'm taking both sides and writing them as a power. I'm exponentiating them. Again, what that's going to do, here it's going to cancel out the exponential and the log. Just leave me with 3. Over here, 3 cubed, 3 times 3 times 3 gives us 27. Okay, second one here. This entire thing is my log. So on this one, there's nothing to isolate. The log, the natural log is already isolated. And so what we're going to do is we're just going to take both sides and exponentiate it. So remember, this has base e here. So I'm going to use my exponential with base e. So e to the natural log of x minus 2 equals e to the third power. Remember, it's not 3 to the e power. Okay, whatever base I put here has to be my base over here. And so again, that's going to cancel those out. On this left side, it's just going to leave me with x minus 2. On the right side, unless we type that into our calculator, we don't know what that is. Okay, and so we're just going to leave that right now as e to the third power. And so what we're going to do, finally to solve that, is take that e to the third power and add our 2. Okay, again, that is our exact answer. We can type that into our calculator and get a rounded answer. If we do that, we're going to get 22.086. Both of those are correct answers. Up here, again, we need to isolate first. Just like any other equation, we want to get rid of the adding 4 before we divide by 2. Okay, and so first thing I'm going to do is subtract my 4. Then we're going to divide both sides by 2. Okay, now remember, this has base 10. It's not there. Okay, but we have to know that because here we're taking this log 10 to the power of log of x minus 1. Again, this is not 2 to the 10th power. It's 10 squared. From there, we know that the exponential of base 10, the log base 10 cancel each other out. Gives us x minus 1, 10 squared, 100. Then we're simply going to add 1 to both sides, and that's going to give us 101. The only thing we have to worry about with these logs, we do kind of have to check our solutions, okay, and make sure we don't get this extraneous solution. The main thing that we're looking for with that is you cannot have a negative number inside the log. Okay, you can't have 0. And so we know that you can't take something to a power and get a negative number or get 0. And so that's really the only thing we're looking for when we're plugging back in to find our solutions. All right, I want you guys to try these 2 examples. So pause your video, try the 2 examples. Once you're done with these 2 examples, play your video and the answers will be there for you. All right, here are your answers. Check your answers. Make sure that you did everything correct. And then go ahead and proceed on to your practice problems.